Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 5th, 2026, just yesterday. It introduces a pioneering benchmark called Rise Video, which finds that while video generators look great, they largely fail at deep reasoning, with even the top model achieving only about 23% accuracy on implicit world rules. The paper is titled, Rise Video, Can Video Generators Decode Implicit World Rules? And as we'll see later, the implications for how we train future world models to understand physics and logic are quite significant. And for those interested in the implementation, the authors have shared their code on GitHub. To illustrate this reasoning gap, Figure 1 presents a test case from the experiential knowledge dimension. The top left shows the input, a man holding a bottle, paired with an instruction to show the process of him drinking. The unwritten rule here is that he must unscrew the cap first. Yet, looking at the generated clips, only Hailuo 2.3 and Veo 3.1 successfully depict this step. The remaining models, like Sora 2, fail to follow the logic and have the character drink from the closed bottle, ignoring physical reality. Figure 2 details the full scope of the benchmark. At the center, a circular chart breaks down the 467 test samples into 8 primary reasoning categories. Surrounding this core, individual panels illustrate specific tasks, such as Panel 7 on the left for subject knowledge, which tests fields like physics. Panel 8 focuses on logical capability, challenging models with game mechanics, while Panel 3 on the right covers temporal knowledge, evaluating how models handle time progression. So, Figure 3 outlines the automated evaluation pipeline used to grade these videos. It stacks 4 metrics vertically, utilizing large multimodal models as judges to scale the process. At the top, reasoning alignment checks if the model followed instructions by asking binary yes or no questions. Moving down, the pipeline assesses temporal consistency and visual quality, before finally checking physical rationality, where it samples 16 frames to ensure the judge catches dynamic physics violations. While the general pipeline handles most scenarios, Figure 4 introduces specialized strategies for schematic puzzles, where standard models struggle. For maze navigation at the top, the system bypasses the judge to strictly track the trajectory path and detect wall collisions. In the middle, the symmetry generation panel verifies structural correctness by comparing the output grid against a ground truth reference. Then, for board games at the bottom, the evaluator receives a visual reference image, which helps it spot specific layout errors that are difficult to capture with text alone. Table 1 reveals the final standings, comparing 11 models across our 4 metrics. The top section lists the closed source models, where Hailuo 2.3 secures the lead with the highest overall accuracy of 22.5%. Other systems shine in specific niches. Notably, Veo 3.1 achieves the best physical rationality score, while Sora 2 leads in temporal consistency. In contrast, the open source models in the bottom half lag significantly behind, with accuracy dropping below 12%, highlighting a major capability gap. Drilling down deeper, Table 2 splits the performance across the 8 specific reasoning dimensions. We see a clear trend where models excel at perceptual tasks, likely because these rely on static visual cues rather than complex dynamics. For instance, WAN 2.6 scores almost 91 here. Yet, looking at the logical and spatial columns, the numbers drop sharply, with even top models rarely passing 25% accuracy. This discrepancy highlights that, while the pixels look right, the underlying physical rules are often broken. Wrapping up, the big takeaway is that visual realism does not equal understanding, as even top models struggle to grasp basic physical laws like gravity or cause and effect. This suggests the next frontier isn't just better pixels, but training models to actually simulate the logic of our world. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.